Okay, good afternoon, everyone. My name is Katie Moe, and this is my talk, APIs for Cyborgs. It was my first ever conference talk when I delivered it for the first time at Signal San Francisco. So thank you very much, Twilio, for inviting me back for something that's now going to be a little bit different. Just another preliminary note, don't feel it's rude to use your laptop or phone. In fact, I'd really appreciate it if anyone who knows how to make an HTTP post request would get out their curl or postman or whatever, because there's a small amount of interactivity to this talk, which you'll see a bit later. Okay, I call this talk APIs for Cyborgs because I consider myself a cyborg. I have a glass-coated NFC transponder implanted in my left hand. And in a few months, I'm considering inserting magnets into my fingers with a scalpel. One of the most common questions I get asked after why would you do this is how. So the chip itself that I have implanted is about 12 millimeters long, 2 millimeters wide, and when I ordered it from the Dangerous Things website, it came packed in a little 10-gauge syringe assembly like this. So I'm going to show you a little bit about the procedure for inserting it into my hand. I've made a little diagram. Oh, here's the syringe. So it kind of went a bit like this. OK, that's probably enough for now. I'm not unique in this. The biohacking community, such as it is growing. And some of you in the audience may be biohackers or grinders yourself. Do we have anyone else who considers himself a DIY cyborg? Maybe. If you do, come and chat to me later, because I want to see if my software is compatible with your hardware. But DIY cyborgs aren't the only type of cyborgs, right? You might consider yourself a cyborg if you've got a pacemaker, or an IUD, or a contraceptive implant, or a bionic limb, of course. So prosthetics have been around for millennia, but wireless networking has not. So my contention is that through the internet, cyborgs are starting to realize their potential. So what does that mean? And to start with, what is a cyborg? My definition of a cyborg has two parts. I'm going to give you the first part now and second part later. So the first part is that a cyborg is someone who has augmented their body's capabilities through permanent non-human hardware. So given this definition, that means that as long as we know what a machine is, we know what a cyborg is. It's a human fused with a machine, a kind of machine and mensch. It wasn't a big decision in my life to become a cyborg, and I think that says more about where we are right now than it does about me. I think that's just where we are. So, the purpose of this talk. You're probably used to the idea, especially having been at the conference today, that everything has an API these days. There's a company I've been in contact with called Mystery Vibe. They make this vibrator. It has a REST API. It's incredible. But the thought that got me started on this talk is that what if there were an API for the human body itself? I can't claim to have created such an API, otherwise this talk would be a little bit more exciting. But this is kind of my preliminary research into the area. And it's just the beginning, and I've been delivering this talk and trying to gather ideas and inspiration from all you people about where this could go and essentially what it means for communications that we have this capability. So just a quick detour, introduction to NFC, in case you're not familiar. So I'm going to give you just a quick crash course in what is NFC. What are the capabilities of this technology? So it's radio communication, the specific frequency, 30.56 megahertz. It's typically got a 1 to 4 centimeter range. So I'm going to show you this antenna a bit later, and I'll have to put it pretty close to my hand in order to read it. The tags themselves, the one I've got in my hand, is passive. It's not powered, there's no battery in there. So in order to actually draw power, it uses the electromagnetic field of the antenna itself. And the data model on this thing, there's a hard-coded unique ID, which is generally put in by the manufacturer, and something called NDEF records, which is a data format for the data that's encoded in the chip. So there are numerous applications for NFC. You may even have used some of them today. Obviously, contactless payment or tickets, your Oyster card or contactless payment card, identity or access tokens. They're sometimes used for access to buildings. So if I were very lucky, I would be able to scan my hand and get access to my office. Sometimes they use proprietary protocols, so it's difficult, but always doable. Smartphone automation. So I have NFC stickers all around my house, and I use them with my Android phone. I tap the phone on there, and it can perform an action. It's completely programmable by me. So I have one, so I come into my house, and I tap the phone on the wall, and it sends a text to my girlfriend saying I'm home. It's just a good way of automating things really quickly with Androids. And it's also used for bootstrapping other protocols. So say you want to make a Bluetooth connection between two devices. Well, you can just tap them on each other. They can exchange all the necessary creds, and then they can actually make that further connection. So that's what NFC basically is. The final thing I have to introduce before we get into some live coding is this Adafruit PN532 antenna. So this, if you can see it in the front rows here, is a small card. It contains an NFC antenna, which is able to read and write from the tag, also emulate tags and things like that. And it's attached to my computer through this serial cable, serial to USB. So let's have a look at the demo. So I mean, naturally, as soon as I had implanted this uniquely identifying chip into my hand, I thought, let's connect it to the internet, to fulfill my dream of being in this globally addressable space, right? And there's also a performance art piece, which I'll talk about later. But for the moment, any of you who've opened curl or Postman, I just want you to note down this URL, https://kmo.herokuapp.com/nfc. So later, maybe you should hit this URL, send a post request to it. All you'll need to do is just send some raw data in the body, no JSON or anything. Cool. So I chose to use JavaScript for this demo. It's kind of becoming a universal language for demos. I mean, it's massively popular. You don't have to wait for it to compile. Super simple. So it's my kind of super simple stack. Yeah. I mean, I made some of these up. But let's go into the demo. OK, so this will be half live coding and half guided coding, because some of these bits in the demo have to be done in a particular way. OK, great. So OK. OK, so I've got a bit of code on the screen. Hopefully, you can see it. So we're in JavaScript land now, so use strict, right? Basically, I'm using Node.js here, and I'm using a couple of really useful Node.js libraries. One of them is called serial port. And serial port allows us to make it a bit easier to communicate over this serial connection we have here. I'm using the ndef library here to parse the records. As I say, this is the data format that we use on the chip. The PN532 library helps us to handle the actual device itself. And then all I have to do is find the devices in all my list of connections, set a baud rate, not very important for now, and then initialize it. OK, so what we're going to do now is we're going to initialize the device just so that we can actually read from an NFC tag. And just to prove that I haven't set this all up, I've got some NFC tags which are not inside my skin. If someone can verify, this is separate, and we can use this to read, and there should be something different on here from the one inside my hand. But for the moment, let's just write some Node, right? OK. So firstly, we have to actually make sure the device is initialized. OK, so the device will be initialized. Once we've got the device, then the way it works, the way the API works is it's based on these events. So we just have to wait for a tag event. A tag event means that a tag has been detected. So if we want, we can just log out everything that's in the tag. But what I already know, we want the UID. So if we recall from earlier, when an NFC device is manufactured, when an NFC tag is manufactured, unique ID is hard-coded in. So naturally, this answers the question, how unique and how hard-coded? It's possible generally to secure this in some way. I mean, manufacturers generally use static signatures, so you can't duplicate the tags. But I've heard of ways of cloning them that won't be a part of this talk. So let's just see if we can get a tag UID, OK? I'm going to run this code. In fact, sorry, one moment. Just need to get rid of this stuff. OK. OK, so it's initialized. And I'm just going to scan a tag on it. This is nothing to do with Cyborgs yet. Undefined, great. That's exactly what I wanted. So what it's done is it's detected the tag. Let's put in a bit of code here. And what I may have done is, there we go, misspelt. OK, so now it's initialized. I'm going to tap the tag on it. And here is what the UID looks like. So this will be dependent on each tag. So if I scan a different tag, I should get a different UID. Sorry, it was this 2 different tags. And now finally, if I scan the one inside my hand, we should have a different ID. Great, so hopefully that shows that unless I've orchestrated this in a very clever way, it's hopefully I've really got an NFC tag in there. OK, so what we want to do now, is read the data that's on the tag. So what I want to do first is to show you the data that's already inside my hand. I may have mentioned that there's only 888 bytes to spare. I mean, it's possible to compress stuff and encode stuff. And if you wanted to put a long number in there, if you want to put your passwords in there, then go ahead. I don't consider it a very secure medium. So let's just read the NDEF data. This will read the data from the tag. And if I am correct thing, it's kind of a mix of event promise-based API. So we could just log out all the data here. In fact, we will, just to see what it looks like. So what we've done is we just read the NDEF data. As I say, it's the encoded data on the tag. And it'll just log it to the console, which is at the bottom of the screen. OK, so we've got a buffer just dumped in there. And I've taken the tag away too early, so it's got a read error now. It's probably not what we really want. So what we're going to do now is going to decode the data according to the NDEF specification, and then we can actually read it in a human-readable format. So, OK. So we have to do a bit of sort of futzing around here because it's Node.js. Let's see what we get here. So what they should have done is just decoded the NDEF records. Again, a little bit fiddly. Great. So what we've got there is, actually, I just touched it on some other tags, so it started going a bit crazy. But if you look at the bottom of the screen, which hopefully you can see, among all the buffers and type fields and stuff like that, we've got some human-readable data, like this YouTube video. And there's a little bit of text, APIs for Cyborgs, 20th September 2016. So that's the data that's currently residing inside here, as encoded as an NDEF record. So what I want to show you now is being able to write to the tag. So I thought I'd make this a bit more interesting. And so this is where the post request comes in from earlier. So if you've posted something to that endpoint, the kmo.herokuapp.com/NFC, then whatever's on that endpoint right now, it's kind of a last in, first out type stack. But if someone's written to that, then I'll be able to just write that to my hand. And it'll almost be as if you've posted something to my hand. I tried to make it interactive. OK, so I don't know what's on that endpoint, and there's no sanitization or anything. So let's have a go. I'm not going to write this right now, because I did that last time, and it overran. So having learned that, let's write some data. So what I'm first going to do is run the write script. OK, so just to take you through the script really quickly, this is very similar to the read script. We wait until it's ready. We wait until a tag is there. We then make a request to this endpoint. All it does is echo back the last thing that was sent to it. It's very simple. And we're going to encode 2 NDEF records that we're going to put onto this tag. So the first one is a YouTube video, which you can view later. And the second one is a text record. So that'll be exactly what was on the body of the request. So let's just do this. OK, let's write it. So the data currently written to the tag, if you can see that, maybe I can zoom in, is help get me out of here, which I think is quite appropriate for a tag that's now trapped inside my skin for who knows how many years until I'm able to get it out of there. Awesome. OK, so I hope that's at least shown you the sort of very basic capabilities of something that we can now talk about in a little more detail. OK, so what I just showed you was a small demo that forms part of a larger project, which I made a couple of months ago to have two-factor authentication using this as a second factor. It's kind of like something you know and something you have implanted in you. So you can find this on my GitHub, but a disclaimer, as I say earlier, is don't try this at home. Tags can be cloned, UIDs can be spoofed. But I thought this would be somewhere towards the idea of the sort of API for the human body idea that I've been approaching. So I'm running out of time. I made a web sequence diagram, but you probably have seen a few of these today, and there's nothing worse than other people's web sequence diagrams. So let me just get through this. OK, so I'm going to just conclude with some thoughts and some further lines of research, and what I think all of this means, and what the capabilities and the potential is for this kind of communications technology. So, I mean, you may have noticed a couple of slides back that the two-factor authentication flow currently only works for me. Not much of a two-factor authentication system, unless anyone else has their own NFC chip whose ID I've hard-coded into my system. This is the limitation of my architecture, but it also raises a wider point about the Internet of Things in general. So consumer IoT devices often ship with proprietary protocols and designed with narrow use cases in mind. So for example, Nest, a few months ago, retired its Revlov device, which it relied on proprietary software and hardware, and it was communicating with the Nest cloud. But with that disabled, Revlov is now just a sort of useless $300 black box. So I thought this was a kind of interesting way of considering how we can actually make our devices talk to each other. And I don't know the answer, but this is a question we're going to all have to grapple with. So I think a more important point, at least as relevant to this example, is that I asked earlier why. Why would I want to become assimilated into this Internet of Things? Why do I want to expose part of my body in a globally addressable space? What if there's a showdown search engine for people's bodies? So at the very beginning of my talk, I mentioned that my definition of a cyborg has two parts. The first is that I've implanted permanently some sort of non-human machine hardware into my body. But the second part is that someone who's augmented their body's capabilities through non-human hardware feels the control flowing the other way as well. Implanting this technology in my body has changed my behavior. It's made me aware. Maybe, if you've got a big enough NFC antenna, then you can extend that 1 to 4 centimeter range. So in what situations am I exposing the data on here to be read by someone I can't even see? I don't put private data on there, but in the future, this is something we're going to have to think about. In fact, the NFC, sorry, Phil, I have to make a digression. The NFC spec authors, they have a section in the spec about security. So you would say, how is this secured? Is there some sort of hardware? Is there some sort of encryption we can do at the hardware level? They allow you to make a PIN, but the spec explicitly says, we recommend security be implemented at the application layer, i.e., you can't really trust NFC security. So I would be wary of putting passwords on this device. So the final thing I want to say is that I really think that we're kind of reaching towards this idea of embodied data here. So I have a couple of examples for what I mean by embodied data. I was at the Tate Modern, and I met an artist called Chloe Spicer. So she explores what it would mean to become a book. She consumes books, she wears books, she makes art with books, and she explores this potential of embodied knowledge, which is, of course, super interesting and relevant to me. Because, I mean, I can remember information, but it's not persistently stored in my brain in any similar way to the way it's stored in a hard drive. And information is encoded in my DNA, maybe in a similar way, but I can't access it. There's a poet called Christian Bock who actually encodes poetry into DNA, has it evolve, has it persist. But I think there's something sort of similar that we can go down here. So the idea of persistently storing information in my body in a way that interfaces with technologies, I think, the potential that we really have to explore here. So I hope this has been at least the start of some interesting ideas, and I look forward to sharing with you the rest of my research and hopefully getting some ideas from you as well. So thank you.